Welcome to Mission Control Houston at NASA's Johnson Space Center, where we are live awaiting the arrival of the SpaceX CRS-28 cargo spacecraft to the International Space Station. Just moments ago, the Cargo Dragon conducted its approach initiation burn, and in about an hour and a half from now, it will dock to the space station's Harmony module. Docking is scheduled to take place at 5:50 a.m. Eastern Time, 4:50 a.m. Central Time. We are providing live coverage of Dragon's approach and docking. Thank you for joining us. This is Mission Control Houston.
Ground 2, approach initiation burn complete. Dragon is 30 minutes to 1,000 meters.
Everybody copy 30 minutes to 1,000 meters. Thank you for the heads up.
You are looking at live views of the Dragon spacecraft on its way to the International Space Station. It launched yesterday morning, Monday, June 5th, from Launch Pad 39A at NASA's Kennedy Space Center in Florida at 11:47 a.m. Eastern Time. By the time it docks, it will be a little over an 18-hour journey to the space station. Docking is on schedule, and it is scheduled to take place at 5:50 a.m. Eastern Time, 4:50 a.m. Central Time. This is a live view of Dragon closing in at 6,200 meters from the space station. It successfully conducted its approach initiation burn that is going to push Dragon on a trajectory to the International Space Station. In about 20 minutes, the Dragon spacecraft will conduct another burn. This is a mid-course burn that's going to fine-tune its path to a point that's about 400 meters below the space station. When CRS-28 does dock to the space station, it's going to be docking to the Zenith port on the Harmony module. Zenith is a celestial term. It means the highest point, or one that is directly above the observer. We don't use north or south because there is no true up or down in space. Often we will say with this port, it is the space-facing port. On this graphic, you can see it there, as well as an outline of Dragon's trajectory. We just completed that approach initiation burn, and we are on our way to waypoint 0, which is about 400 meters below the space station. CRS stands for Commercial Resupply Service. This is SpaceX's 28th contracted commercial resupply service mission for NASA. CRS-27 docked to the forward port, but we are docking to the Zenith port today because it is very close to the Canadarm2, which is the robotic arm built by the Canadian Space Agency. A key reason why we need access to this robotic arm is because of a very important piece of hardware being delivered to the space station as part of this more than 7,000 pounds of cargo being delivered. And this is the third set of IROSA. IROSA stands for the International Space Station Rollout Solar Array. These are new arrays that are being installed on the space station. They're about 60 feet long and 20 feet wide. Although they are smaller than the old space station arrays, they are much more efficient. Once all of them are installed, we are expecting a 30% increase in power production. This set being launched and arriving today on SpaceX CRS-28, it's going to take 2 EVAs or spacewalks to install them. Those are coming up on June 9th and June 15th, and we are providing live coverage during those spacewalks. Most recently, the Zenith port was vacated by the AX-2 vehicle. AX-2 stands for the Axiom 2 mission. This was the second private astronaut mission to the space station by Axiom Space. That crew flew on a SpaceX Dragon vehicle named Freedom. They splashed down on May 30th. Prior to that, the Zenith port was occupied by the Crew 6 capsule. That is also a SpaceX Dragon named Endeavour, and it is still docked to the space station, currently on the forward module, or the forward port. In anticipation of CRS-28 needing that Zenith port, it was relocated on Saturday, May 6th from Zenith to the forward port. After Crew 6's spacecraft was moved to the forward port, it freed it up for Axiom 2 spacecraft Freedom to dock to it, and then undock, splash down, and now CRS-28 can dock to the Zenith port.
With you on 2, Steve.
Okay, I was trying to get my ARED going a little bit early, and when I opened up the ARED app, I got a Windows security alert. Windows Defender Firewall has blocked some features of this app, which I don't remember from the last time I opened it up this way, and I was wondering if that was expected.
And Steve, that was not expected. We are checking.
Okay, it does give me some options to check. It already has the domain networks checked, but then private networks, and the third one is public networks. I was wondering if I should just check them all, or I'll just wait for what you say.
You are looking at live views of the SpaceX CRS-28 cargo spacecraft on its way to the International Space Station, closing in just under 4,000 meters from the station. We are about 30 minutes away from the Dragon spacecraft reaching that first milestone, which is going to be waypoint 0. Before that, the spacecraft will conduct a mid-course burn that is just going to fine-tune its path for it to reach waypoint 0. We will not pause at waypoint 0, and we will continue then to waypoint.
Station Houston on Space to Ground 2 for Steve and ARED.
Go ahead on 2.
Steve, it's going to take us a little while to come up with a solution for you, but you are go for ARED without the software.
Okay, I understand. I'll work through it without the software. Basically, I should just turn off the box, right? Is that the instrumentation box?
Checking. And Steve, you can go ahead and turn off the instrumentation box.
Okay, thanks a lot.
That was the voice of NASA astronaut Steve Bowen speaking with the Capcom position here in Mission Control Houston. Capcom, or capsule communicator, is the voice link between the crew and the flight control team. Today we have Eber Zavala. To his left is our flight director, Chris Dobbins. He is part of the class of 2022 flight directors. He is NASA's 102nd flight director, and his call sign is Ignis Flight. He was inspired to pursue a career in spaceflight when he was a child after learning about Apollo 13 and the work that the flight engineers did in helping to save the crew and return them safely to Earth. You heard the voice of NASA astronaut Steve Bowen, but throughout our docking you will hear a lot of NASA astronaut Woody Hoberg. He is going to be prime for monitoring the arrival of the Dragon spacecraft to the station. Although Dragon is flying autonomously, commands are able to be sent, both from SpaceX's teams in Hawthorne, California, as well as Woody on station. CRS-28 will stay docked to the space station for 3 weeks, and it will deliver over 7,000 pounds of supplies for the Expedition 69 crew. The Expedition 69 crew members are currently living and working aboard the International Space Station. Dragon is approaching the west coast of Africa, and we are less than 8 minutes away from that mid-course burn. That's going to be our final burn to position Dragon at the waypoint 0 marker. Waypoint 0 is just at the cusp of what's called the approach ellipsoid. It is a marker that denotes joint operations because of station safety. After Dragon crosses through waypoint 0, it is on its way to waypoint 1. Waypoint 1 is right at the cusp of what's called the keep-out sphere. This is another invisible line around the station. It is closely monitored by the flight controllers, as it is very close, only about 200 meters in radius.
Station Houston on Space to Ground 2 for Frank and shutters.
Roger.
Hey, Frank, we're getting close to that time where we need the lab shutter closed, so just calling to send you a friendly reminder to knock that out at your earliest convenience.
Yep, those are closed.
And can you confirm that the cupola shutter is also closed? And the lab?
Affirmative. Also affirmative.
Okay, Frank, we copy. Lab and cupola shutters are closed. Thank you very much.
No problem, thank you.
Capcom Ever Zavala was speaking with NASA astronaut Frank Rubio. Ahead of some housekeeping items preparing for CRX-28's arrival. He confirmed that the lab windows and the windows on the cupola are going to be closed prior to the rendezvous and docking. If you are just joining us, you are looking at live views of the CRS-28 cargo spacecraft on its way to the International Space Station. Dragon is less than 2,000 meters from the space station. The nose cone is open and swung up, as you can see. And the nose cone is going to remain pointed at the station throughout the rest of its trajectories. Coming up, teams are going to poll for a go, no go to proceed through that waypoint 0. About 1 minute out from that mid-course burn.
As a station on 2 for Westerby.
Meridian 2, Sultan.
Just like to know, like you to know that the Westerby docking station is powered on now.
And we copy all. Thank you very much.
Mid-course burn is in progress. "20 seconds remaining in the burn. And we just received confirmation that that burn was nominal. Nominal means normal or performed as expected. Dragon is on track to dock at approximately 5:50 a.m. Eastern Time, 4:50 a.m. Central Time. These various burns that Dragon is performing on orbit come from its Draco thrusters. There are 16 total Draco thrusters on Dragon. 12 specifically are around the service section on the lower portion of the capsule. They are automatically firing to maintain Dragon navigating correctly to the space station. Teams are currently polling for Dragon to cross that waypoint 0 and continue its journey to the space station. Waypoint 0 is about 400 meters below the space station. The team is also working to get Dragon Eye enabled. Dragon uses a GPS, global positioning system, and also an RGPS, which is a relative GPS. With GPS, the spacecraft communicates with those GPS satellites to know where it is in space. For the RGPS, the spacecraft has navigation sensors and antenna that are talking directly to the space station. Together, these two methods say where space station and Dragon are in relation to each other and help inform Dragon's flight computer on where to go. Once closer to station, the Dragon Eye will take over. It's located on the very top of Dragon, and it uses LiDAR, which stands for light detection and ranging. These are laser sensors that ping off of different reflectors on the space station. They give high fidelity data on the real-time distance and the rate of closure and where it needs to line up on those docking targets to help guide that final approach.
Station Houston on Space to Ground 2. Dragon range is approximately 1,000 meters. Monitor long range approach per steps 1 to 4 in 1.102 Dragon approach and retreat monitoring.
Every station copies. We have Dragon in sight and attitude is as expected.
Copy, Dragon in sight. Attitude as expected.
You just heard NASA astronaut Woody Hoberg confirming that they have sight on the Dragon spacecraft and that everything is proceeding nominally. On board the space station, NASA astronaut Woody Hoberg is going to be monitoring the arrival of the SpaceX CRS-28 spacecraft. He has a series of tools and capabilities on board to monitor its arrival, and he can send commands if necessary. During Dragon's approach, the attitude of the station is very important to make sure that the spacecraft can properly line up and dock to the station. Teams are using large gyroscopes to help maintain and control the attitude of the station, or which way it is pointing. It'll continue to stay in this position as the spacecraft swings out in front and up and around so that it meets that docking axis for the zenith port on the Harmony module. On the Dragon Eye with that LiDAR system, those bouncing lasers back and forth are going to give the spacecraft very valuable real-time data on its location as it approaches. We just entered an expected LOS, or loss of signal. As the space station flies around the Earth, those communication paths need to transfer to each satellite. Teams here in Mission Control taking a brief break while we have that loss of signal. We are expected to get that signal back in just a few minutes. SpaceX's 28th contracted commercial resupply service mission is bringing over 7,000 pounds of cargo to the International Space Station. This includes important experiments, hardware, and supplies to the crew living and working in space right now. Just a few of these experiments. One is called What Happens Above Thunderstorms, or Thor Davis. This is an investigation from the European Space Agency. It observes thunderstorms from the space station. The unique vantage point of the space station allows researchers to see the electrical activity from above, particularly the inception, frequency, and altitude of recently discovered blue discharges. Scientists plan to estimate the energy of these phenomena to determine their effect on the atmosphere. A better understanding of lightning and electrical activity in Earth's atmosphere could improve atmospheric models and provide a better understanding of Earth's climate and weather. Another experiment of note is helping plants chill in space. Plants exposed to environmental stress, including spaceflight, they undergo changes to adapt, but those changes may not necessarily be passed on to the next generation of plants. The Plant Habitat 3 experiment assesses whether plants grown in space can transfer such adaptations to the next generation of plants, and if so, whether a change continues through subsequent generations or if it stabilizes. This investigation creates a second generation of plants using seeds previously produced in space and then returned to Earth. Results could provide insight into how to grow multiple generations of plants to provide food and other services on future space missions. This investigation also could support development of strategies for adapting crops and other economically important plants to marginal and reclaimed habitats back here on Earth. The Dragon spacecraft is closing in on 400 meters below space station. That's going to be that waypoint 0. And we just received confirmation that the Dragon Eye link is successful. That is now going to be the primary method of Dragon navigating to the space station. This is a very precise LiDAR-based system. LiDAR stands for light detection and ranging. These are lasers that are going to be pinging off of different reflectors on the space station. It's going to give the spacecraft high-fidelity data on its distance and rate of closure. Once we get to that docking axis, it will also help it to fine-tune and line up and guide that final approach. "90 seconds from waypoint 0. 20 seconds, waypoint 0. Dragon is passing through waypoint 0. The spacecraft is now less than 400 meters from the space station. Next up is going to be waypoint 1. This is going to bring the spacecraft out in front of space station and up and above so that it can reach that docking access. We are going to the zenith port on the Harmony module. You can see it highlighted.
Station on 2, we see ourselves in step 2. Prior range is 381, attitude as expected.
We copy attitude as expected, and you're in step 2.
Capcom Aver Zavala speaking with NASA astronaut Woody Hoberg. Woody has been radioing performance calls down here to the team, confirming that everything is looking as expected as the Dragon spacecraft heads to that waypoint 1. The Dragon spacecraft is going to reach that docking access in about 30 minutes from now. Just like we passed through waypoint 0, traditionally we are not going to pause at waypoint 1. However, we are going to make a 1-minute pause at waypoint 2. That is just 20 meters away from the space station, so teams want to ensure that Dragon is properly lined up and that the station is ready to receive the spacecraft. In just about 45 minutes from now, CRS-28 is expected to make contact for that initial capture. Its docking ring will interact with that international docking adapter like two hands grasping each other. It's going to pull it in close for hooks on Dragon to latch onto the station and do what's called a hard mate. Once those hooks engage, it's going to create a vacuum-tight seal and create a vestibule that the crew can later pressurize and then open hatches to remove the cargo. Before Dragon is considered fully docked, umbilicals from Dragon will also connect to the space station. Those umbilicals will enable the spacecraft to connect to the space station's power and data systems. It will then enter what's called a quiescent mode. Here in Mission Control Houston, teams are working alongside SpaceX's Mission Control team members in Hawthorne, California. They are working through go, no go polls as Dragon makes its way through a series of important milestones before it docks to the space station. Flight Director Chris Dobbins is leading the flight control team here in Mission Control Houston. He is responsible for the real-time crew safety, vehicle safety, and mission success from NASA's side. As in the Apollo era, the flight director has ultimate decision authority and responsibility for the mission. The main voice you are hearing communicating with the crew on board today is the Capcom position, that is Eber Zavala. Capcom stands for the Capsule Communicator. They are the voice link between the crew and the flight control team. We are heading into an orbital sunset, but we should still be able to see Dragon in the dark. Those flashes on either side are the thrusters in action, performing those maneuvers to keep Dragon on that trajectory to reach its docking axis and dock to the space station. Currently, it is headed to waypoint 1, which is going to position it about 220 meters away from the space station. The nose cone is open. You can see that navigation light blinking. Once we reach that orbital nighttime, you will see a green and a red light on either side of the spacecraft. The red and green light mimics those on nautical lights. The starboard or right side is green, and then the port side on the left is red. Teams are currently polling for that go, no go to pass through waypoint 1, much like we passed through waypoint 0. However, once we get to waypoint 2, we do have a 1-minute pause that is planned. That pause will ensure the final alignment to the docking port. We are only 20 meters away at that point. Dragon is currently using its Dragon Eye systems to navigate to waypoint 1. This is a LiDAR system. It uses lasers to bounce off different reflectors on the space station to give immediate real-time data to its flight computer. The nose cone is open, and it is going to remain in this orientation with the nose cone facing the station all the way up. In this orbital nighttime, we may be able to see those thrusters firing occasionally to keep Dragon in this orientation and bring it all the way up to waypoint 1. The colored dots you see on the screen right now are dead pixels. This video is coming down from a camera on space station. Those cameras are exposed to the radiation environment of space. Because of that, those pixels can degrade and die in space. It's much more obvious at night. And we can see now very nicely those red and green navigation lights on the port and starboard side. Port is red and the green is the starboard. Dragon is largely flying itself right now, but NASA astronaut Woody Hoburg is on station assisting teams here in Mission Control Houston. Woody served as the pilot for the Crew 6 mission. They launched on March 2nd, 2023. Woody also monitored the docking and docking of the previous SpaceX cargo resupply mission, the CRS-27. Woody was selected as an astronaut in 2017, and this is his first trip to space. In a little over 30 minutes from now, at 5:50 a.m. Eastern Time, 4:50 a.m. Central Time, CRS-28 is going to dock to the International Space Station. It will stay docked for approximately 3 weeks. Its current undock date is scheduled for June 27th, later this month. The Cargo Dragon spacecraft will be docking.
Station on 2, passing the V-bar. Attitude remains as expected. Pri range 468.
And we copy Pri range 468 and good attitude.
NASA astronaut Woody Hoburg confirming to teams here in Mission Control Houston that everything is looking good from his end. Behind the scenes, teams are consulting with the VVO console position. This is the Visiting Vehicle Officer. They provide visiting rendezvous expertise and integration with Mission Control Houston. NASA astronaut Woody Hoburg is part of Expedition 69. These are the crew members currently living and working aboard the International Space Station. They include NASA astronaut Frank Rubio, Roscosmos cosmonaut Dmitry Petelin, Emirati Space Agency astronaut Sultan Al-Nayati, NASA astronauts Woody Hoburg and Steve Bowen, and Roscosmos cosmonauts Andrei Fedyaev and Sergei Prokopyev. And we are about 15 minutes away from the Dragon spacecraft reaching that waypoint 1. So far on its rendezvous journey, Dragon successfully conducted an approach initiation burn followed by a mid-course burn. Together, those positioned it at waypoint 0, which is about 400 meters directly below the space station. Because we are going to the zenith port today, Dragon is reaching waypoint 1 at about 220 meters away from the space station. It will then be aligned on that docking axis and make its way down to waypoint 2, where we will pause for 1 minute before it makes that final approach and capture. The capture ring mechanism is on the very top of Dragon, and it will make the initial contact with the station and then draw it in closer to that docking adapter. To make that hard mate with the space station, there's a total of 12 hooks that will latch into the docking adapter. They will create that sealed environment between Dragon and the station. We call that a vestibule. Dragon will also deploy its umbilicals to connect it to the power and data systems of the space station. The crew on board can then begin to pressurize that area. They're going to make it the same pressure as that on station, 14.7 psi. They will then conduct some leak checks and then be able to open the hatches and start bringing the cargo in later today. In addition to experiments, food, and supplies for the crew, hardware is also being launched as part of the more than 7,000 pounds being delivered today aboard CRS-28. A very important set of hardware is the iROSA. These are 2 panels that will provide solar power to the station. This is the 3rd set of iROSA that are being delivered to the space station. They are
Station Houston on Space to Ground 2. Houston and station are go for Dragon to approach to 20 meters.
Station copies, go for approach to waypoint 2.
Capcom Iver Zavala just confirmed to NASA astronaut Woody Hoburg aboard station that teams have pulled go. Dragon will pass through waypoint 1 without a pause, and it will approach waypoint 2, and it will pause there for at least 1 minute. As mentioned on the delivery of that 3rd set of iROSA, it is going to take 2 spacewalks to install those. Those spacewalks are coming up on June 9th and June 15th. Once all 4 sets are installed on space station, we are expecting a 30% increase in power production over the station's current arrays. The prime reason we are going to the Zenith port today is because it is close to the Canadarm2, which is the robotic arm that will assist in getting those solar arrays installed. We are currently still in an orbital nighttime, but you can see Dragon's navigation light flashing on the screen. These are live views coming down from a camera aboard the International Space Station. We are just about 20 minutes away from that initial contact and capture of the Dragon spacecraft. Docking is on schedule for 5:50 a.m. Eastern Time, 4:50 a.m. Central Time. And we are about 8 minutes away from Dragon reaching that waypoint 1, which is about 220 meters away from the space station, and that is also going to position it on its docking axis to move into that zenith port. The zenith port is the space-facing port. Less than 20 minutes away from SpaceX's 28th contracted commercial resupply service mission for NASA to the International Space Station. The Dragon spacecraft launched on Monday, June 5th at 11:47 a.m. Eastern Time aboard a SpaceX Falcon 9 rocket from NASA's Kennedy Space Center in Florida. NASA's commercial space program has enabled successful partnerships with American companies to resupply the International Space Station. Through this strategy, NASA is achieving its goal of safe, reliable, and cost-effective access to and from the International Space Station and low Earth orbit, while also helping to build a strong American commercial space industry. Dragon is getting ready to proceed through waypoint 1. And teams are polling for a go, no go for that final docking. This Dragon cargo spacecraft, CRS-28, is expected to remain docked for 3 weeks and return to Earth on June 27th. This is not its first flight. It's actually its 4th flight of this Dragon capsule. It was previously flown on CRS-21, 23, and 25. After each flight, these SpaceX Dragon capsules undergo refurbishment. Similarly, the launch vehicle, this Falcon 9 rocket that launched CRS-28 into orbit, it was the 5th flight of that booster. You are now seeing live views from a camera in the nose cone of Dragon. This is an overlay that NASA astronaut Woody Hoburg also sees on his laptop. It is using the centerline video from Dragon. Some important items to pay attention to here. At the top left, you will see the range and the range rate. These numbers are showing how far Dragon is away from the station and how quickly it is approaching. When we
Station Houston on Space to Ground 2 at waypoint 2. Dragon will briefly pause to align for docking, then automatically resume approach.
Whenever station copies.
Capcom Iver Zavala speaking with NASA astronaut Woody Hoburg aboard the International Space Station. Teams here in Mission Control Houston and SpaceX teams in Hawthorne, California say all things are go for Dragon to approach waypoint 2. The vehicle will pause there for just about a minute to make sure that final alignment is on track for its docking. It is now crossing into that keep out sphere until it is just 20 meters away from the space station. The keep out sphere is an invisible line around the station. It is monitored very closely by flight controllers because it is so close to the station. It's about 200 meters in radius. It allows for 4 orbits of safety if the vehicle were to lose control in a very unlikely situation. This keep out sphere gives crew on orbit those command capabilities because it is close to the station. Dragon is traveling directly down to waypoint 2. It is on its docking axis, ready to dock to the Zenith port on the space station's Harmony module. The Zenith port is the
Station on 2 for step 3, block Bravo. The vehicle attitude is as expected.
Copy, vehicle attitude as expected.
confirmation from NASA astronaut Woody Hoberg on station that the attitude of the spacecraft is performing as expected. The attitude is which way it is pointing. We are less than 10 minutes away from that initial contact and capture. Just about 5 minutes out from teams polling go, no go for that final Dragon docking. We are going to pause for about a minute at waypoint 2. After that, Dragon will close in on its range for that contact and capture. At about 5 minutes from the station, we will hear a call out for CHOP. This stands for the crew hands off point.
Houston Station on 2, our review is complete and ISS is ready for docking.
And we copy, crew is ready for docking.
NASA astronaut Woody Hoberg has confirmed that the station is prepared to receive Dragon. We are still waiting on mission control teams here back on Earth to also poll go for the docking. We are currently in an expected loss of signal, and we are going to remain that way through the initial docking. We will still have audio, we will just not have video views. Again, this loss of signal is expected as the space station flies around the Earth. Those communication paths need to transfer to different satellites. However, we may regain those video views right at the end of docking. Dragon is just 100 meters away from the space station, approaching that waypoint 2, which is about 20 meters from the space station. The vehicle is slowing down as it approaches waypoint 2, where it will pause for 1 minute. It is currently traveling at 0.3 meters per second. Just a few moments away from the SpaceX CRS-28 cargo spacecraft, making initial contact with the International Space Station. The capture ring on Dragon will interact with the International Docking Adapter. It will bring Dragon in for its 12 hooks to engage and do a hard mate with the space station. Those hooks will create that tight seal with the space station. Then umbilicals will connect with the space station. That will enable Dragon to enter what's called the quiescent mode, where it can utilize the power and data systems of the space station. The cabin of the Dragon spacecraft, as well as that vestibule area, will be pressurized and synced with the space station atmosphere. Essentially, they'll become like another module when they are on space station. "30 seconds from waypoint 2. Waypoint 2 is the final milestone before Dragon makes contact with the space station. Docking is going to occur a few minutes behind the timeline, but no issues with Dragon's approach. Dragon has arrived at waypoint 2. We are going to pause here for about a minute to ensure that that final alignment final alignment is on track for Dragon to make that final approach.
Station Houston on space to ground 2. Dragon is on final approach and is go for docking. Monitor per steps 5 and 6 and 1.102. Dragon approach and retreat monitoring.
Station copies. We see approach 2, pry range is 18.5 and decreasing. Range rate looks good.
And Houston copies.
Dragon has proceeded past waypoint 2 and it is approaching the station about 16 meters away. Again, we are in an expected loss of signal for our video views. We are expected to get those back.
Station block Bravo, attitude as expected, max error about half a degree.
Copy, attitude as expected, max error 0.5 degrees.
Dragon is approaching 10 meters away from the space station. Approach is nominal. Range rate is 0.08 meters per second. Five meters away. Four meters. 3 meters.
2 hands off point.
Copy, crew hands off. Dragon contact and soft capture complete.
Station copies and concurs.
Capture is complete at 5:54 a.m. Eastern Time, 4:54 a.m. Central Time, off the coast of Brazil.
Ring retraction in progress.
Station copies.
That capture ring is now interacting with the international docking adapter, drawing Dragon close in for those hooks to engage and do a hard mate with the space station. Again, we are in an expected loss of signal for our video views. As the space station passes around the Earth, those feeds are transferred between satellites. We are expected to regain those video views right towards the end of our full docking completion. Just in case you missed it, SpaceX's CRS-28 cargo resupply spacecraft successfully docked to the zenith port of the Harmony module on the International Space Station at 5:54 a.m. Eastern Time, 4:54 a.m. Central Time, while the space station was flying off the coast of Brazil. The capture ring is currently drawing Dragon into that international docking adapter.
Ring retraction complete. Docking sequence is holding for MCS reconfiguration.
Station copies.
Teams here in Mission Control Houston just let the crew aboard the International Space Station know that the MCS is ready for reconfiguration. MCS stands for the Motion Control System. For Dragon's approach, the thrusters on the Russian segment were disabled in order to stabilize the station for Dragon's approach. The station was being stabilized exclusively by those control motion gyroscopes, because we have that successful capture of this.
MCS configured, proceeding with hook driving.
Because we have that successful capture, those thrusters are going to be re-enabled, and you also heard confirmation that those hooks are beginning to drive. The Dragon spacecraft is latching itself securely into the space station. The hooks are latching nominally, or performing normally as expected. Those 12 hooks aboard the Dragon spacecraft are currently latching into space station, but that does not complete our docking. We also need to connect a series of umbilicals from the spacecraft to the space station. The first set of hooks are closed, and the second set is currently driving. The final set of hooks are proceeding nominally, and we have regained our video views. You are looking at a camera view from inside Dragon. You can see the spacecraft is docked to that international docking adapter on the space station.
Hard capture complete.
That hard capture has been completed. All of those hooks have latched into the space station.
Station copies. Hard capture complete.
Next up are going to be those umbilicals from Dragon connecting its data and power systems to the space station. Here is a view of the SpaceX CRS-28 cargo spacecraft successfully docked to the Zenith port, or the space-facing port, on the Harmony module of the International Space Station. Right now, those umbilicals from Dragon are connecting to the space station. Dragon has solar arrays and batteries for its free flight. However, when it is docked to the space station, it enters a quiescent mode where it can power down its systems and essentially plug into the space station, able to draw on the station's much more powerful systems. We have a successful tight seal with Dragon in the space station, thanks to 12 hooks that have successfully latched into that international docking adapter. It's creating a vestibule that the crew will soon pressurize. They will then conduct leak checks and be able to open the hatch and start removing the cargo later today. And docking is complete. We heard confirmation from Mission Control team members in Houston that we have a successful docking complete. The SpaceX CRS-28 Dragon cargo spacecraft docked successfully to the International Space Station at 5:54 a.m. Eastern Time, while the space station was flying over the coast of Brazil. The cargo spacecraft is scheduled to remain docked for
vestibule pressurization, step 1.1.
And Frank, please stand by. We need another minute.
Okay, no worries, thanks.
Crew on board is waiting for that go-ahead to begin pressurizing before they will conduct those leak checks and remove the cargo later today. CRS-28 is scheduled to remain docked for 3 weeks and will return to Earth later this month on June 27th. NASA astronaut Woody Hoberg was on board monitoring arrival.
Station Houston on Space to Ground 2 for Frank. You are go for 1.1 and 2.2.
Copy, go, thanks, over.
And NASA astronaut Frank Rubio is going to be assisting in the pressurizing of the vestibule and spacecraft. This concludes our coverage, but you can continue to follow the crew along on our blog at blogs.nasa.gov/spacestation. Thank you for joining us. This is Mission Control Houston.